Now we are going to see about the structure of agents part 2. The title it will be a learning agent. A learning agent in AI is the type of agent which can learn from its past experience or it has a learning capabilities. It starts to act with basic knowledge and then able to act and adapt automatically through learning. There will be 4 main components: the performance element, learning element, critic, problem generator. In performance element, this selects external actions taken, it perceives and decides on action. Learning element, it is responsible for making improvement by observing preferences. Performance. Critic, learning element takes feedback from critic which describe how well the agent is doing with respect to a fixed performance standard. Problem generator, this component is responsible for suggesting action that will lead to new and informative experience. Learning agent diagrammatic representation, it's so how the components are involvement in their agent areas. First one, it is a performance element, next it is an learning element, next it is an critic, then it is a problem generator. Next title, it is an how components of agent programs work. So there will be 3 types. First one atomic, second one factored, third one structured. The 3 ways to represent states and transition between them. Number 1A, atomic representation. A state such as B or C is a black box with no internal structure. Number B, it is an factor representation. A state consists of a vector of attribute values. The values can be Boolean, real valued, or one of a fixed set of symbols. The last one, it is a structured representation. A state includes object, each of which may have attributes of its own as well as relationships to other object. In depth we are going to see about the each types, how the components of agent programs works. Atomic representation. In atomic representation, each state of world is indivisible. It has no internal structure. Consider the problem of finding a driving route from one end of a country to the other via some sequence of cities. A second type, it is a factor representation. A factor representation splits up each state into a fixed set of variables or attributes, or each of which can have a value. While 2 different atomic states have nothing in common, they are just different black boxes. 2 different factor states can share some attributes, such as being at some particular GPS location and not the other, such as having lot of gases or having no gas. This makes it much easier to work out how to learn one state in another. Next one, with the factor representation we can also request uncertainty. For example, ignorance about the amount of gas in tank can be represented by leaving the attribute blank. The last representation is a structured representation. We need to understand the world as having things in it that are related to each other, not just variable with values. For example, we might notice that a large trunk ahead of us is reversing into the driveway of a dairy farm, but a cow has got loose and it's blocking the truck's path. A factor representation is unlikely to be pre-equipped with the attribute a trunk ahead backing into dairy farm, driveway blocked by the loose cow, with the value of true or false. Instead, we would need a structured representation in which objects such as cow and truck as other various and varying relationships may be described explicitly. A structured representation underlining relational database and first order logic, first order probability models, knowledge based on much of natural language understanding. In fact, almost everything that human express in natural language concern objects and their relationships. Thank you.